Hello everybody, it's Tech here. Hey. Hello everybody, it's Tech here. Hey, back for more. Back with different research screen than where we left it last night. So last night, when you go into the research screen, it would have a scroll bar at the bottom of the screen. And I'm going to show this. This scroll bar is gone now. I thought on it long and hard and realized that we wouldn't have enough space vertically for all of the different pieces. Hey, Spiderman. You came in for just to say first and then leave. Okay. This is how it's going to function now. Basically, you can click and drag around, move it vertically, horizontally. It basically gives me infinite space in which to present the icons on the screen for the different research on the different tree nodes. Okay, so that was step one. Step two then was to take that concept and hook it into the research, what I'm calling research topics. So what you're researching about, because I didn't want to call them researches because it sounded funny. So research topics. And setting up a registry for them, which is simply a hash map, right? It takes the name and then stores the research class. The research itself, I've decided instead of putting it as a child of the team info class, will instead just have a array of unlocks binary Boolean values. Hey, Space Engineers. And that array is going to correlate to each of the teams, right? Because we don't need to know the key parent, the resource values, the X and the Y coordinates, and calculated levels, and anything else I can think of for each of the teams. That is something we only need once. It's whether or not that team has that research completed that's really important. Okay. Then we started on the mod research. We register everything, and now we're down to where we can calculate the level. So you can think the level as, is this the parent node or is this a child node? And if it's a child node, how many children deep into the structure is it? That's what we're trying to calculate with this. Why do I need to calculate this? Because the next thing we're going to try and calculate is what the parent's X and Y value is, but we need to know what the X and Y value of the parent is in order to do that, right? So we're going to have to figure out what is the top node, what is level 1, give it an X value. Then anything that's one layer deeper than that is going to be off to the right of that. Those are going to be a higher level or calculated level, so we can figure out what that X value is. Then once we figure out the X values, we can start separating them by some Y distance as well. So that's the thought process, and that's where we're starting off tonight, because I've got some bug in here. If I were to let this run, it would crash. It's going to crash because there's something with a null in it. And I think this code might have fixed it, but I didn't have time to test it when I had to step away earlier. So let's let this run and see where it's going to error off at. Now, can I remove multiples at a time? I bet I can. Remove. Okay, so this is what we're interested in, what's left over here, right? So let's continue to watch this. We are currently at level, what, 1. It's after level 2 that it errors off. So if I were to watch this as well, when we see this say level 2, we need to stop. Okay, we're at level 2 now. And we've got the battering rams is what we're at. We're clear down here. Okay. Guess these aren't in order. Now we're at the Lancer minion. So we're at the Lancer with its parent of minion. Okay, we're good at that. We're going into the next level deep. So the Lancer minion. LM. Okay. I'm going to go into that one. And we immediately go to Battering Ram Siege Workshop. Lancer minion again. Crossbow archer. Armory minion. we're basically in this looking for this parent key value here, Lancer. So where are we going to find a Lancer at? We won't. And this is probably where it airs off. It's on the minion and null. So parent key is going to be null. So this would not work before, because parent key, I guess parent key is null, but what's this? This one wasn't null, and that was the issue. I think this portion here is going to correct it though. And it looks like it did. Good. So I'm going to remove the breakpoints or disable them for the moment and see, does it crash? And it doesn't look like it did. Amazing. Did it? It did not. Awesome. Okay, so now we're going to look for research topic inside the log and look at what all these are. So minion is level 1. That is correct because it is the top level. Lancer and Armory are 2. Lancer is minion. Armory is minion. Advanced Armor is 3. Advanced Armor is got its parent. Here you go. Of Armory. Armory has its parent and minions, so that is 3. Marketplace is 2. Siege Workshop is 2. Battering Rams is 3. Trebuchet is 4. That's correct. Archer is 2. Crossbows 3. That's correct. Pikeman's 2. Walls 2. Watchtowers 3. I think we got it. Thanks, Flip. So this should work. Well, that was really what I was trying to achieve, was this structure, so that we can then calculate the X values off of that, okay? So now that we've done that, we need to calculate X's. So there's a couple things we'll have to do. The X value we can multiply by this current level. So let's do that. Calculate. And this is something we're only going to do on startup, so it's not like it's going to be a big time sink all the time. So we can do as complex a calculation as we want. Calculate X value. And we need to do this for everything, so I don't know if there's any parameters we really need to pass for this. So let's create that method then. We're going to just copy and paste, cheat a little bit. And it's going to ask me to terminate. We will terminate because we have to restart this to test it. Once it realizes that I've made a change, we're just going to close anyway. Okay, calculate X value. And we're going to loop through every entry set through the whole research topics, all of them. And we're going to say for entry set, get the value. And we're going to say get. Did I not create a calculated value on that? Oh, yeah, it was right there. Calculated value. Okay, so we're going to do that. And then we're going to say get the entry value. Dot set parent X. I think we need to first set our own X. So let's first do that. We're going to create a couple more my X. And you might be thinking, why does it need to know its parent? Well, it needs to know its parent because I think of current, I guess. It needs to know its parent or the child, whichever, so we can draw connecting lines between them, right? Knowing what those are is very important for that. What the current button is and where its parent is, and we can take the current from current to parent and draw a line between the two. Okay, so let's, where is it? Source, setters, and getters. We want that one and that one. Okay. And I put them above everything. Dang it. I hate it when it does that. I didn't mean to do that. Put them here, please. Okay, so we don't want to do parent x, we want to do current x. We're dealing with the current x equals that times some unknown offset value. Now, this unknown offset value we'll define as a private static int x spacing. X sp, and we'll set this to say 10. Okay. So we're going to take that calculated value and multiply by spacing, x spacing. We need to set current value. Set current x. Okay. That gets all of the research nodes, research topics set up with their x values. Now we need to space them vertically along each of these levels. Okay, and can we somehow figure out what our max level is? We will want to do that. So let's create another variable, private static int max levels, and we're going to set it to 0. I got to keep it static. Max levels is going to equal in here. It's easy. Max levels equals math helper dot clamp. Wait. What is a clamp? Yeah, I think it's. No, it's not clamp. We need to just do an if statement. So max levels equals if max levels is less than level, then max levels equals level. So if level's bigger, it'll set it to be that. Okay, so that gives us the maximum number of levels we need to go through. Now, what did I do that for? I did that so we can do a for loop up here for int I equals 0 and I is less than max levels and less than or equal to max levels. We're only going to start at 1 though. Okay, so let's do that. I plus plus. Oops. There we go. And now we calculate the y value. No, we need to get a count of how many have that same level first. So we'll create another method. Yeah, I'm trying to make a research screen that looks really good. At least that's the goal. So Fusion, this is the prototype of it with lots of dumbness to it right now, but we're trying to make it smart where these will be connected by lines to show what's the hierarchy of the research that you need to do. Right, so you need to do this one before you do those two kind of thing. Trying to make it pretty. Let's see how it works though. Calculate y value by counting. Okay, we're gonna call that, and we're gonna give it a level, which will be I. level int. Okay, so now the idea behind this is that we need to figure out how many are within there and split them up. But do we need to do that? Yeah, we do. We want to make it pretty. If we don't want to make it pretty, we don't have to. And I'll explain what I mean by that in a second, hopefully. So let's first create a Y spacing value. And those values are likely to change a lot. Okay, so we're going to loop through the entry set again, all of our topics. And we're going to set the Y value, but not based on the calculated value. Instead, we're going to do Y spacing as well. Instead, we're first going to count how many there are. So this is a secondary loop, if you will. The first loop is going to count how many are within this level. So we're going to say level, get calculated level. If that equals level, I'm going to int. I'm trying to set up a way of laying out where those researches should be on the screen dynamically so that as we add more researches, I don't have to code in the values of where each node should be. That's the long expression, long way of saying it. Hey, Fusion. Int count equals 0. So count equals count plus 1. And then we can just say count is wait. Count is how much vertical space we need to take up. How much vertical space we need to take up, so let's define that. Int vert space equals how many we're dealing with, and vert space divided by 2 gives us the center point. So if I subtract off how many we're currently on, so int I equals 0, I plus plus, I minus I times Y spacing. I think that's right, but I could be horribly wrong. And probably am, but we'll figure it out. Okay, so that should calculate both of those in one pass for each level. The next thing we need to do then is in our research screen, add the buttons for each one of these. Which right now we're just setting it to hard code this. Not ideal, but it is what it is. So let's keep one as an example. We'll comment that one out just so I can refer to it. Oops, I can hit the right button. There we go. And we want to create a for loop. The same kind of for loop, actually. Because that is a public thing. So mod research. Mod research topics. We don't care about the levels like that. So now we're going to say add button, new research button. Okay, and then all these fun values. So this.GUI left plus GUI utility left button offset. Nah, it's not even needed. So it's going to be the, let's do this. Entry.getValue. Just cache this to a research class. Research R. Dot. And it will be R dot get current X. Get current Y will be here. So this dot GUI top. I'm kind of watching myself, right? Do I have to say it? Then the width is going to be 20. The height is going to be 18. Those numbers don't change. This bit here I need to add to the actual research thing. So we're going to have the same appearance of the button for now, which should be fine. It needs to be 19 there. And that is our texture. And on button click, I'll have to sort out how to do that. Do there. And the text in is going to be r dot get translation key name. Our screen is going to be this, and our X offset is going to be the current. Okay. This value and this value. Okay, what'd I do wrong? Got the right number of parentheses. That takes us up to there. This one takes us up to there. We got the 18, the 20. We're then doing the two different X, Y coordinates like we were doing up there to figure out which button it is. The 18 or the 19, the button. Then the pressable type stuff. Getting the translation key, returning this, the buttons X and Y coordinates. This should all be good. Doubles versus integers. Okay, that's helpful to know. I'm assuming this takes doubles, this takes integers. Okay, so we just got to cast them to integers. Simple enough. Is that the only ones? Still thinks it's doubles. Okay. Int. Last two values. Okay. Oh, you're signing Fusion up for work now? Okay, let's see if this works. If this works, we'll have all of the buttons defined on the screen, and they will be spread out left to right and vertically based on the hierarchy. What I expect it to happen is crash 3 times and also be like a jumbled mess and not actually what I want. Oh, you give like a crazy encrypted message and then you mess it up? Come on. Node the world. Actually work. Amaze me. The spacing's off.
That's not that bad.
Minion name. Siege Workshop. Marketplace. Armory. Lancer. Those should all be at that level. Not sure what... Oh, that's 2 of 1 top shop workshop name. Archer. Trebuchet should be all the way to the right, and it is. Advanced Armorer. Okay. Watchtower. Crossbow. Battering ram. This is mostly working. I do see one thing I didn't anticipate, though, and that is the vertical sort order of these. It's not in an order I think we can use, so I'm going to have to figure out this one's Y value is at the top, so this one needs to be at the top if it's a parent or something, because we're going to get lines crossing each other. Okay, so first off, let's make these spaced out much more horizontally. Vertical spacing as well. We need to probably do 10 plus the height of these individual buttons themselves. We also need to bump it down a bit so that it starts somewhere down here. Okay.
Not to interrupt you, but Scooter, isn't that just the alphabet except for G? It's supposed to be J in the one place.
Huh. He said yep. Research. So in the mod research, we need to set the spacing to, let's say, let's assume it's 20 on both. So we're going to set them to 30. That should give us 10 spacing between the nodes. Unfortunately, I have to restart the whole thing to calculate that again, which is annoying. And you know what? I'm going to also change one more thing. That would give us nice spacing this way, but we need some more space in there so we have room for the lines. So let's set it to, like, if we want 30, that'll give us 10 in between. If we wanted a whole nother button worth in between, we would want another 30 there. So let's make it 60 X spacing. Try that. So setting things up to be on the same vertical y-axis as their parent might be a challenge. Because something like Minion has multiple children, and all of those children need to be centered around it. So our y calculation is completely wrong for what it needs to be. Yeah. We also need to look for like parents and go to those. If we started from the bottom up, that might be one advantage we could do. We could look to see where the archer has minion, the lancer has minion, the pikeman has minion, and so on, and do all of those. Maybe. Okay, we've got too much spacing now. It's a crossbowman, that's an archer. Yeah, way too much spacing somehow. So let's make it 20 and 40, 50, yeah, 40. It's really weird to me. You ruined the plant economy in your modded server? Uh oh. Let's create one more method down here. Private, static, void, update all calcs. What that's going to do is just call those because I want to call this from somewhere else easily. Mainly our research screen. Where it initializes, it calls update all calcs on those. So mod research dot that, like that. Oh, it's private. We need to make it public. I have 2 stacks of superemium essence. Wow. Mystic agriculture. Come on, please work. It's machine not compatible, awesome. Okay, so we've got minion, armory, lancer. Seems to stop after just a few, and I don't understand that. Yeah, and CZ, your 1 milestone, there's no way I'm getting all this done by Saturday, man. Like, it's just not happening. This alone will probably take me the rest of the week if it's just going to be as complicated as I think it's going to be. And I hope you feel better. Why am I only getting 5 buttons? Let's go back to 10 and see what's up. Does not recalculate those values, dang it. I'm gonna make it recalculate them. Yeah, that's all temporary, man. When it goes off screen, they're supposed to disappear. It's just not rendering half of a button, is what you're seeing. That's why they all disappear at once, right? So they disappear before it's all the way off. I'm checking it because otherwise what would happen was you would see the edge of it on the edge of the screen. Like right there, how it's kind of going over the edge. I didn't calculate it quite right there. So one step at a time. I just need to override the rendering method in this thing. It's also not an end of the world kind of thing if it does that. Okay, so this works. It's probably because these are going up too high and I have my vertical axis limited on this to 0 on my research screen. That's what I'm thinking. So let's change that lower limit. There's a clamp somewhere in here I need to get rid of or modify right here. So we'll set it to negative total scroll units. And the same for this. So we're giving ourselves a great big scroll area now. And let's go back and set our heights to something a bit bigger. We'll say 15 and 15. And switch screens. Cool, there it is. We've almost got the width we need. Oops, not 2. Let's set it back to 40. It should give us a full button in between, because I kind of want some nice spacing in between these things. There we go, that's some good spacing. So what I think I'm going to do is I'm going to come out here with a line from this to this, right? And it's not going to be a straight line. It's going to go halfway between them, go straight down, and then back across. Yeah, Spooderman, you figured it out. So it'll be a Z shape almost, right? So we can look at each one of these buttons, or the research tied to it. Okay. Get the research, find its parent key and its key, and then draw a line between them. How do I get... There we go. There's sticks because I haven't set them to the proper icon. Because I don't have that field set up. And it's just placeholder where I work things out, man. There'll be something different when I'm done. Okay, let's increase the Y value a little bit more. Go to 20. In theory, that should put them right on top of each other pretty much. We also need to center this at where they actually are. So that's an okay amount of distance. Ah, I'm seeing something else here. Okay, so this is a blank spot because this one's here. So when we're calculating our Y values here, calculating the vertical space, dividing it by 2. We're not doing it for a given level. Okay, so that's part of our problem. So this level here needs checked in here as well. That should help. There we go. Nice. Perfect. Not perfect, but perfect for what I want for so far. So this one, minion, is connected to all of these, because minion's the root of everything. Then this advanced armor is a child of only one of these. And it is this one. So what we kind of need to do is take each key, because I've got a parent and a child. So each parent key, and look through all of the other keys and see if this one's a child of that. If it is, we need to keep track of how many children it has. Figure that out, and figure out how many children the children have, or grandchildren if you will, and great-grandchildren. So really we need to start from the bottom up. So we need to look at the great-great-great-great-great-grandchild, figure out how many are at the same level or share the same parent, and set that parent to be spaced so that we can fit vertically all of the children that it has. So let's see if I can Photoshop something to make sense for myself and for people watching the stream. Because that's what this whole research thing has been for me today and yesterday, is I need to understand it at a very low level what we're trying to accomplish in order to code it. Once I understand what it needs to do, coding it's not the hard part. It's understanding it right now. Okay, so basically if we do, let's do some lines maybe. Okay, so we're gonna have a parent over here, right? And it's gonna link up to its children, and the children are gonna be vertically separated like this, and each have their own little offshoot from the main branch there. Something like that, right? But the problem is, this child that's here might have two children of its own. So coming out of that one, it might be something like this. Right? And that's okay as long as we only have one child of all of these children. Right? So if you think of these as level 1s, and this is 2s, and these are 3s and 4s, as long as the 2s don't each have a level 3, we're okay. Or as long as they don't have any further children. But as soon as you start multiplying things out, we need to calculate extra space for this guy because he's extra wide on his children. And again, this could be set up where these also have 2 more children or 6 more children. We just don't know. I want this to be dynamic. So we need to go to the end of each tree, because these are like trees, or each branch. Need to go to the bottom of the family tree and figure out how wide it should be. Okay, Spider-Man. Catch you later. This is not going to be as easy as I thought, I don't think. Because I get what I've got to do, but now trying to translate that. Like, how do we calculate what the distance is of, say, this one? Oh, you're going to bed? Good night. And also, where do we position things? And this is already kind of solved in Minecraft like this. So somehow this monster hunter knows that it has 4 children, and that it needs enough room to make 4 spots to the right of it before the next one down is. And the same with this. It's got 2 there, probably a third that we don't see or something. Or maybe this one has a bunch of room. I don't know. So if you look at these, this is spaced 1 between. But this is spaced more than 1 between. So there's like 1.5 there. Wait a minute, I think I might have an idea. We can traverse down to the bottom of the whole branch. Know that this one takes 10, this one takes 10. This is 10, this is 10, this is 10, this is 10, and add up. So this would be 10. Itself is 10, so we don't need any more. And all of these are 10, so this needs 4 space. Then this one gets to know from its children. So like this one would need 2. And And this one probably needs 2. I just can't see the other one for whatever reason. Basically, we start at the bottom level and go up the tree, passing what our width is, or height is, whatever. It might work. I can hear it in my head. I'm just trying to think it through. I'd actually have to write down on a piece of paper, guys. So each one of those are 1. So we just sum them up. That'd be a total of 3. Be a total of 2, 1, 1, 2, and then 2, 1, 2, 3. So that'd be 6 and 3. That means we need a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. Okay. So we need to go to the lowest nodes, count them. So if this was the lowest node, we'd count all 4 of these and put that value into this. Then count all of these children, put it into this. These children, put it into this. And these children, put it into this. Then we repeat the same thing for the top level or the next level up, getting not just how many there are, but the values that we received from the lower levels. And if there was none in the lower level, it automatically is a 1, because we could have a node that doesn't end. And that gets us the total number of spaces we need vertically to hold everything. Yeah, now let's code that. Okay, so we already walked the tree down vertically from the very top to figure out the level indication. Okay. We could, and I think this is what we need to do because we've already got that level calculated. In this one, we can calculate if we're at that level, get the parent, and set the parent's special value, or I don't know what this is called, node count, whatever. Tree node count, whatever we're going to call this thing. So private int tree node value. Okay, and we're going to set a create getters and setters for this. We are going to create them after our constructor. There we go. Yes, Terminator code. You know what? Let's make a commit first before I do this, because this is going to break all sorts of stuff. Research GUI structure and research topic setup. Still with. Okay, so now we can go back to this if we really royally screw it. So we don't need this count necessarily. Instead, we just look up the parent of each of these ones within this level and set that parent's value to what it needs to be. So entry.getValue dot parent key if that is not null. Right, because eventually we're going to get to the top of the tree and don't need to do this anymore. We take We just add 1 to the parent. On this value, yeah. It's parent key. So we say research topics dot get that value, that parent dot set. It's something node. I know I get tree node was set tree node. There we go. And it's going to be adding 1 to whatever it already was. So we take all of that, make it a get, and add 1. Okay, that gives us the count of total vertical space we need to occupy. Which is better than this count we had. But we'll only know that once we've gone through the entire tree. So this needs to be its own method then. That gets called multiple times as well. So we're gonna do this. So calculate node, tree node, node value. Don't worry about the count, don't worry about that. We're gonna do this in here first before we do anything else. And we're going to do it for every single level, but we need to do it from bottom up instead of top down in order for this to work. So to do from top up, we need to go start with max levels until while I is equal to or greater than or equal to 1. And we say minus minus. Okay. And I got these reversed. I want that one to be there and this one to be here. And I don't think we need this anymore. Instead, we will say research topics get. We need to find the parent node, which is going to be minion. Minion. Dot get tree node value. Now, I'm uncertain about a lot of this, so let's just run and see what we get. I think this works. This is like a Huffman tree, I think it's called. But the Huffman trees are often used for something completely different. Bye. Bye, Fusion. It's different, but the Huffman tree inspired me. Look up Huffman trees, that's about sorting in alphabets. Oh, right, that's for compression, was what it is. Yeah, no worries, man. Where is it? I don't see it. I'm trying to look for it. Perhaps we've given it a horrible, horrible value here. Yeah, okay. Nowhere to be found. Okay, so let's do this then. Let's set these to really small again, so it gets all compressed on top of itself till we can find it. Okay. The ship started at 0, so I'm not sure why this is going so far in. Is it because our current scroll and values are funky? No. Well, maybe we need to step through this and figure out what we get. Okay. Tree node value, which we get here. Perhaps it never was received or something. It's 0. So let's enable breakpoints and click off of it, back on it. And we're at calculate levels. Not sure why we're stopping there, but we are. Please get out of my face. There we go. We're at 42. That doesn't sound quite right, does it? It's not, because we added 1 to it. Now that's the problem. It should be a much lower number. I don't know what the number should be, but it should be much lower. Only the bottom value needs the 1 added to it, or if there is no more children. Gosh, do we need to set up what our child is on this to make this simpler, so we know if we're at the bottom? I'm probably not going to get this tonight, guys. This is going to be a very complicated thing. Let's put it that way. So if I just do that, okay, so this is what we can do. We know our value is .get tree node value. So if it is equal to 0, then we can set it to something. And what we're going to set it to is 1, right? Because we don't have a value yet. And when we set that, no, set it to 1. When we set that value, then we can use that value here, adding it to whatever the parent's value already is. So effectively, we're not adding 1 on the parents for every parent in the tree. This should help. Okay, let's close off and go back into it. And our tree node value is 79, even bigger. That's because we haven't reset everything. Great. This is only an issue because we didn't restart the game. We could reset them first. I don't really want to do that, but we might have to. Normally you wouldn't have to, it's only when we're recalculating. So, to do remove next line if this is ran in startup only. It's here for debugging. Debugging only. Still spelled it wrong. And it's just a call to clear. Let's just do it this way. Okay, and we'll say entry.getValue dot set tree node value to 0. Ta-da, reset everything. Hey, that's better. Okay, we got something we can find now. Why are you airing off? How did we get 2 of them? And I copy and paste it. I must have not realized it. How did that work? I don't get it. Okay, so now we can set these to something realistic. 40 is probably extreme, but we'll try it. Oh my gosh, I just realized why it's jumping over there so far. It's because when we're setting the X spacing, calculate the X value, we need to do that. Because we don't start at level 0, we start at level 1. And there we go. At least now it's on the screen. Trebuchet, battering ram. Might be there. We might be there. And by there, I mean we're close. What the heck? We're no longer centered in it, but gotta figure out how to align these across. Let's do this. Do we want to draw the button lines? On our research button, we have our offset. That's it. We don't have a reference to what the node is. We don't even have the key. Do we? Might need to save the key. Yeah, we don't have the key in here. So on the research button, if we save what the key is, we can look up the key, get its child or its parent, and go from there. Draw a line to its parent. Be easy enough for me to say something like r.get key. Then over on research button, wherever that went to, we say an extra parameter string key public. Oh my gosh, get on the right home row. String key this dot key equals key. And then back here, we're good to go. As soon as we hit save, yep. Then can we, in this loop, look at the button's key? rb.get that key. rb.get we need two buttons. And that's also why things are kind of starting in a funky place. We're trying to center them in the screen and also adding 100 to it. Plus we're using X offset for that. Cool. Which is completely wrong. Instead of the Y offset. Tempted to get rid of that altogether, but I don't want to do that yet. We'll get rid of the 100 though. Let's rerun the game. Where's your air? Oh. I was gonna do lines, but we don't have the structure set up yet. Okay, I'm gonna do this test, see if it shows up on the screen better, and we'll go from there. This needs lots of baby steps. Please show on the screen immediately. Tapping to scroll. There we go. Okay. I can live with that. So we need to go from this button to its parent position. rb.get. We don't have the parents though, do we, in the button? But when we set up the button, current X and current Y are set and passed to the next to last parameter, which is our offset X and Y. And that offset X and Y value is used to calculate its position. So if we had the parent positions stored on the buttons, we could use potentially the buttons for this whole thing. Let's try that. string parent key int parent offset x lowercase p, please. Int parent offset y public. What? No. String parent key public int this dot parent. Yep. Continue for now. We gotta just go back over here and fix it. So r dot get parent key and that parent get parent x. Sorry, what? Okay, so we've got our X or Y, we've got our points of where we need to draw a line. I don't know that there is a line method in this, but we're going to try. So this dot line. Ooh, there is lines. Yay. Okay, so we need a horizontal line. Yes, please. Horizontal line needs to be 4 coordinates, huh? I'm assuming that's our starting position and our ending horizontal position and a color. Let's look. So 1 and 2 might be both on the same horizontal plane because it's trying to flip them basically. And number 3 is what though? Number 3 is the horizontal plane that it's in. So start X, end X, Y, color. Because fill is a color if it's doing this. So this is going to be color. Y value. And end or start doesn't make a difference. So rb dot get dot x offset plus this mess and rb dot parent key dot that mess plus that mess. Okay. And our Y value is going to be whatever we're at. And not parent key. Parent X. That. And our color is going to be the value from this website that I'm going to look up for Minecraft colors. Minecraft color codes. Decimal for white is this. I think this is the correct value. Method int. It's not applicable for double int. Okay, cast it to ints then. Don't be a jerk. We gotta cast that to an int too. What's not an integer? Saving world because we crashed. Cool. No such field error. How does that even work? Must have been because I was already running. Okay, we'll try running one more time. See if we get some crazy horizontal lines that connect up to the completely wrong thing. Right? They'll be... they'll go in the right direction at least. Let's put it that way. Hopefully. So right now they're going to go from the starting point to the ending point of the buttons horizontally at the level of the child, but not actually connect to the parent because there's no vertical line to do that with. Also, this is not correct. I need to separate this horizontal line so it doesn't do the complete distance. It goes half of the distance to the parent. But baby steps, like I said. Okay, I'm not sure if we're getting in line. Are we? Is that what's in the corner of those images? Is that what that is? It very well could be. Did we screw up where we're adding the buttons and get current Y, get parent Y, X, parent. Okay. Parent, offset. Parent, offset, offset. It seems like it's just a single dot because that's where the thing is, but let's try this. I'm gonna keep this open, say on this side of my screen. We can see those kind of weird looking things in the corner there, or at least I can. If I do this and save, yeah, they disappear. They're definitely drawing lines. It's just they're the wrong position. Well, the first thing I know I need to do is plus 10 on the y-axis. Really, that didn't do anything. Huh. I figured it'd move it down, because instead of being in the upper left-hand corner. And that's a cool effect. They all disappear when we hover over them. That's new. They don't do it without the buttons there, or without that drawing code. That's awesome. Makes me question if this is going to work at all then. We certainly don't want them disappearing. Maybe this code's in the wrong spot. Maybe it needs to not be in the background layer. Draw container background layer. Maybe just be in foreground layer for it to work right. It's almost like they're disappearing though, which is weird to me. We are outside of all the other if statements though. So this is one. Yeah, we're outside of that one. Because these determine if they are invisible or not for when you drag them off the screen like that. Okay, let's get rid of this and this. So it won't actually be on the buttons anymore then. Really? It's still showing there. That's mind-blowing. Is it our color? Interesting, they go all the way black across the whole thing. It's almost like it's drawing it on the button itself. -10. And we're going back to the parent, which should be to the left of it, so plus 21. No change in any of this stuff we do. Okay, what about -1 on this, so it's off the top? Nothing. Huh. I guess we can say this. $60? Does it change the color? Yep. It's drawing in the background of the button, guys. I don't know if this class does what I think, or this call does what I think it does anymore. I thought it was drawing a horizontal line. Let's look at the fill command, because, well, it's kind of filling it, isn't it? It's getting our positions, so 0, 3, 2, 1. Yep. And it's position 2 plus 1. And it switches around 1 or 2 depending on if they're bigger or smaller. So from the smaller position to the bigger position along the same y-axis with color code 4. So x1, y1, x2, y2 plus color. That to me sounds like something that's doing a x1 to y1, yep, from x2 to y2. Yeah, those are the y coordinates for sure. And these are the x coordinates. So we've got a correct understanding of what it's doing. Okay, guys, well, I guess I need to save this for another night. I'm not going to figure this one out tonight. I already suggest that I'll catch y'all tomorrow.